Greetings, Joseph Kursky here with you. In this video, let's analyze data with ArcGIS Online. ArcGIS Online is a geographic information systems running in the cloud, and it has analysis tools. Recall that we collected data with Survey 123, which is another part of that ArcGIS platform. We went out and collected data, on this case, storm drains. We then created a map with a bunch of layers in it that were relevant to our study, namely river systems, watersheds, etc. And now we're adding a few map notes. In this case, I'm using the classic map viewer. In the new map viewer, it would be called a sketch, but it's the same concept. You're adding notes to the map, points, lines, and polygons, as I'm doing here, a couple of push pins. And from those push pins, I'm going to run a couple of analysis tools. Wow, okay, so very simply here, I've got a couple of points where I've gone out with my students and I've collected some data. In this case, as you can see in Western New York, point 1 in the south, point 2 in the north. Or let's say I didn't even go out to those locations. I just am interested in studying those points on the map and finding out where the countryside around those points drains to. So this is all part of our hydrography study. Now I can check out those 2 points that I've symbolized, as you saw me do there with a push pin. You can choose any symbol you want. You can import your own custom symbol as you see fit. But in this case, I've got 2 points on there, 2 map notes, or in the new map viewer, it's called a sketch. Same idea though, you're adding your own content to a map. This is in itself a very powerful kind of a operation. So in this case, I'm changing the symbol right now to something that may be a little bit more, let's make it blue because it's water. So let's do that. And let's also make a push pin. So let's go scrolling down. There's that push pin, so I can make it look similar to the push pin down south. And I'm going to bump up the size here in a bit so that it's a little easier to see at small scales. Maybe I'll just type in 31 point symbol there. There we go. That's looking pretty good. All right. Customizing the map. So not just because it's there and not just because you can customize your maps, but the idea is to foster understanding, in this case about watersheds and river systems and water quality and so on. So I've got a couple of map notes here. Now see that trace downstream from that one map note? How did I do that? I went to the analysis tools and I said, okay, trace downstream from that push pin or that map note to wherever it flows out into a big body of water. In this case, as you can see, Lake Ontario to the north. Fascinating and scalable too. So if I zoom in, I'm getting a very nice trace. I can measure that with some measure tools and so on. But within a few clicks and within about 10 seconds, I had a nice trace downstream. The classic, if I dumped a bucket of water at this location, where does it flow? And then, of course, why does it matter that it flows that way? Let's go ahead and bump up the symbology so we can more clearly see it. Let's make it a bluish color and a 4-point thick font. Ah, look at that. It's going all the way down to Lake Ontario over one of the most beautiful areas in the world, Niagara Falls. Fascinating to be able to do this. So let's zoom in on Niagara Falls. If this is a part of my lesson with the students, okay, I've dumped the bucket of water and it's going to flow over that part of Niagara Falls. And in another video and tutorial, we'll make a 3D scene out of that, which might be even more conducive to understanding. Okay, so now I'm going to change it back to terrain with labels is a nice one because then I can see some hills, some mountains, some valleys, so I can really give this some context. Wonderful. All right, so that's my trace from the northern point. What about this southern point? It's not too far away, and I can use the measure tool to measure the distance in miles or kilometers, but look at this dotted line here from my addition of data that I did in the last exercise or last tutorial and video that I showed you. Wow, now I see that that point, even though it's not that far away, it's in a completely different watershed. So if I run a trace downstream with the analysis tools and bump up the size for the result, with the same font and the same color as I used for pixel thickness, I can see that that trace from that point in southwestern New York goes a long ways, much farther to get to a large body of water than the northern point. It's going down. What is the name of this river here? Let's have the students look at that so we can see that you've got some local river names here. It's flowing from one. You can do some analysis with the thickness of the width of the river with a satellite image. You can have them measure. It's going on down to the Allegheny, then at Pittsburgh. It's flowing into the Ohio River for quite a few hundred miles/kilometers. And then at Cairo, Illinois, it's joining the Mississippi system, so it becomes the Mississippi River all the way down to New Orleans and down to the Gulf of Mexico. What does it look like right there? Vastly different from my own local area. So let's take a look at the satellite image briefly and talk about deltaic deposits and why they exist, and the Nile and the Mississippi and many other places around the world. Fascinating. So we can also, of course, measure the distance that that stream trace follows, that bucket of water follows, as it's winding its way from southwestern New York to the Gulf of Mexico. Fascinating. So let's trace down from Lake Ontario on down the St. Lawrence into the Atlantic Ocean, the Gulf of Mexico flowing into the Atlantic Ocean as well. So talking to the students about that. Now from the ground, this watershed boundary doesn't look like a very significant boundary, but again, that's the nice thing about teaching about scale. It may not look like much from the ground, but if you zoom out a little bit, sometimes at smaller scales, you see patterns that you don't see at a larger scale. In this case, you see the watershed boundaries. And so even though it doesn't look like much from the ground, it's a vastly important part of the physical environment of southwestern New York, because the rivers drain in a completely different direction depending on what side of the boundary you're on. So we've done a trace downstream from 2 different points. And now I'm running another analysis tool on watersheds. Give me everything that drains into the point that I'm standing on right now and taking maybe water quality samples. And then when we look at floods and flood stages and so on, well, okay, what area does this point drain from versus a point that's maybe a short distance away? You might find that point short distance away is a vastly bigger area of data of water that actually flows into that spot. So fascinating to be able to do this with just a few clicks. And this analysis tool is create watersheds. And just like the trace downstream, you input the point that you want to trace downstream, and here you're inputting where do you want to create a watershed from. Again, easy to do, powerful, fascinating, and it's all about teaching about water. Thanks, and start engaging your students in using these powerful yet easy to use analysis tools. Thanks.